Hi, everyone. Welcome to our Ignite session, How to be a Data Scientist on Azure. I'm Sherry Yang. I'm a content developer on the Data and AI team, and I'll be one of your event moderators. We have some other awesome Microsofties not on camera who will also be answering your questions today in the chat. It's my pleasure to introduce your speaker, Graham Malcolm. Graham is a principal content development PM on our data science and AI team at Microsoft. As an experienced software engineer, he specializes in machine learning and AI on the Azure platform. His recent projects include developing the certification content for AI engineering and data science. All right, take it away, Graham.
Thanks, Sherry, and hi. Thanks for joining us on this session. I hope you're going to enjoy it. As Sherry says, she will be monitoring your Q&A questions as you type them in. We also have Elena and Mary Jo on the back end of that chat as well, so please just keep the questions coming as we go through. I'm basically going to take you on a half-hour journey where we're going to look at some of the kind of key things you need to know to be a data scientist on Azure. Or to put it another way, we're going to have some adventures with pythons, pandas, and penguins, which sounds like a lot more fun. So let's dive in. Half an hour is not a lot of time to do this, so we're going to go at quite a pace, but do rest assured that everything that we cover today, there is online training that you can follow up with afterwards. So I want you to be confident that you can get some ideas on this presentation today as we go through it quickly, and then you can go through it again at your own leisure later on. So let's start off with what a data scientist does. And typically, a data scientist is going to be involved in preparing and exploring data. So they're going to work with a data set, and they're going to analyze that data and clean it up and prepare it for modeling and that type of thing. Well, that all sounds a bit abstract. So let's look at an example. And this is why we're talking about Python, pandas, and penguins. The language that we're using here is Python, and it's a programming language that's used extensively by data scientists to work with data. The library we're going to use to work with data is a library called pandas. So we're using pandas to work with tables of data. And the actual data we're looking at was collected by some scientists on the Palmer Islands who are studying penguins. So that's why we're looking at Python, pandas, and penguins. So here's an example of that data. We've got just a sample, a randomly taken sample of 10 rows of that data. And what we're looking at is some measurements of a penguin. We've gone out and we've measured some of these penguins. The culmen length and culmen depth. You're probably wondering what on earth a culmen is. The culmen is the bill or the beak of the penguin. So we've got the length and the depth of that in millimeters. We've got the length of the penguin's flippers in millimeters again, and we've got the body mass as well in grams. So we've got a lot of measurements that we've taken of these penguins. And we also have some sort of indicator of the species of the penguin. And we can only see numbers 0 and 1 here. There's actually 3 different species. There's 0, 1, and 2 are the different species of penguins that we are working with. And what we're going to try and experiment with as data scientists is to see, is there some relationship that we can exploit between these different measurements and the species? In other words, could we, based on the measurements, make a good estimate of what we think that species of penguin might be if we didn't already know? So it's probably helpful if we know what the different species are. And this really just kind of shows you some of the power of a language like Python and using the pandas library. We've got these 3 different classes of penguin, 3 different species, Amelie, Gentoo, and Chinstrap. And what we're going to do is we're going to take this table of data that we've got, and we're going to create a new column in here called species name that will apply the species name based on the number, the location in that list, 0, 1, or 2, Amelie, Gentoo, or Chinstrap. So if I run that code, I very quickly get a new table up, and now I can see the individual species names of these penguins that I've got. So I've got some Gentoos and some Amelies in here. I don't have any Chinstraps in this sample, but we'll see some later on. All right, so what might a data scientist do? Well, one of the things that we might want to do is do some cleaning up of the data, preparing the data for us to work with it, making sure that all of the data that we've got is actually useful. And I can actually see in one of these rows, I've got some weird values in here. I've got NaN in this row here. What does that mean? Well, NaN stands for not a number. So there's obviously something wrong with this row of data. I've got missing values for my measurements. And that's not really going to be very useful. So we should find out if we've got any more of those kind of rows, any more rows that have missing values. So we'll use this isNull function to check and see, do we have any null rows? And sure enough, there are 2 rows in my collection of data about penguins where I've got these not a number values in here. So I've got some missing data. So what we'll probably do, we've actually got quite a lot of data here, so we probably don't need those 2 rows. We can do without them. So we'll just drop them. We'll get rid of those rows. And then we'll just check and see, just confirm that there are no more rows where there are null values for any of these columns. So we've done a bit of cleaning up of the data. In reality, as a data scientist, we'd spend a lot more time than that cleaning up the data. We would go through and we would look for values that are perhaps outliers that look like they might be, miscoded or wrong. We'd look for missing values like we just did. We'd go through and try and make sure we've got as clean a set of data that is representative of what we expect the penguin measurements to be like, so that we're able to do some analysis against that clean data. So let's assume that we've done that. We've got some nice clean data now that we want to analyze. And the first thing I probably want to do is to try and investigate this potential relationship between these different columns, which I'll call the features of the penguin. So it's common length and depth, and the flipper length and the body mass, these features, and I'll compare these with regard to the species. And the species I'm going to call the label. The label is generally the thing you're trying to predict in machine learning. We call the label. So we have these features that we're interested in, and we want to compare the distribution of those by this species value. So I'm going to do that by creating some plots or some charts, if you like. And this first one here is showing me this thing here is called a box and whiskers chart. It's showing me the distribution of all the values that there are for the Kalman length. So for species 0, the Kalman length ranges from down here, way at the bottom, up to around 46, something like that. That's the kind of the spread of those values. And the median is this green line here. So the median kind of Kalman length for species 0 is just under 40. Whereas the median for species 1 and for species 2 is higher than that. It's just above 45, between 45 and 50. So I can already see that typically species 0 tends to have a shorter Kalman. And I can then look at the Kalman depth and I can see, well, it's a slightly different story here. In this case, species 1, the range of values is much lower, whereas the range of the values for the Kalman depth for species 0 and 2 is a little bit higher. So there's a difference there between species 0 and species 1. Just by looking at the bill, I could get some sort of clue of what species it was. And then if I look at the flipper length, well, species 1 tends to have a much longer flipper length than the other 2 species of penguin. And interestingly, it also tends to have a higher body mass. And that makes me suspect that species 1 is probably a bigger penguin, right? It's got a longer flipper, so it's probably taller, and it tends to be heavier, so it's probably bigger. So just by looking at the distribution of these measurements, I'm already starting to see that there's probably some relationship in the combination of these different measurements, these different features, and the species of penguin that I'm looking at. And I might be able to exploit that. So you can see I've made a little note here that species 0, which is the Amelie, tends to have a short but a deep Kalman, and it tends to have short flippers and a low body mass. Gen 2s tend to have a medium length and a thin Kalman, and long flippers and a high body mass. And the chin strap tends to have a long and deep Kalman and medium length flippers. So by some combination of these measures, I can start to make a good estimate of what species this might be. And that kind of leads us into machine learning. Machine learning is exactly about exploiting these kind of relationships in the data. What we're actually going to do is we're going to take these different features, we are going to apply these features to an algorithm that will find the relationship between those features and the thing we're trying to predict, the label, in this case, the species. And because what we're trying to do is predict a species, we're trying to predict a discrete categorization, if you like, or a class. This is a type of machine learning called classification. We're trying to classify these penguins into their different species based on the features that we can measure. So what we're going to do is we're going to initially take some of this data that we've got. We've got data that has the features and the labels. We've got both of those values for the penguins that we've already observed. And I'm going to take that. I'm just going to run this code and then explain what it does. What I'm doing is I'm splitting that data into two big sets of data. I've got a set of data that I'm going to use to train my machine learning model with. This is what I'm going to apply my algorithm to. And I've also kept back, I'm holding back a set of data that I will use to validate the model after I've trained it. So what I've got in this first set is a collection of features. I'm just showing the first 5. So here's 5 penguins. These are the measurements for those 5 penguins. And these are the corresponding labels. These are the actual species of those 5 penguins. And I've got the same kind of structure that I'm going to validate my model with. I'm going to use that first lot to train a model, and then I've got some features of my penguins that I can use the model to get predictions for. I can predict the labels from those, and then compare those predicted labels to the actual labels that I already know, the labels that I've held back. So I can measure how well my model is performing. So having split that data up into those two data sets, there is, incidentally, there's 239 rows of my training data set and 103 in my test data set. And that split, that kind of 70 to 30% split is fairly kind of regular. That's pretty standard as to what I would do for training a model. So I'll train it with 70% and validate it with 30%. And the specific algorithm that I'm going to use, there's lots of algorithms that I could use for training a model, but I'm going to use this algorithm called Logistic Regression. And Logistic Regression is a very well-established type of algorithm. It's basically going to take those feature values. It's going to try and produce a value of between 0 and 1 for each of the different possible classes. And that value is the probability that this particular observation belongs to that class, or that this set of measurements means it's that particular species. So I'll get a prediction out of this that gives me the probability of each of the different possible species. There is a little parameter here. I've set this regularization parameter in here. You don't really have to worry too much about that. All that's doing is just allowing for a little bit of random variance so that I don't end up with a model that works really well with the data that I've already got, where I already know the species of the penguin, but doesn't generalize well to new data. So we're just injecting that little parameter. And you can actually see, here's the definition of my model. There's a whole bunch of different parameters that we're not going to go into on this short session. But if you were doing this for real, if you were building a lot of machine learning models, you would get to know each of these different hyperparameters, and you might try different parameter values and see how that affects the performance of the model. But in this case, we've now got a logistic regression model. It was as easy as that. We've applied that algorithm. We've what we call fit the data to the algorithm. So we've created a model, and with that model, I could now feed that my data that I held back, my training, my test data that I held back, and I could see how well it predicts against that test data. So if I go and run that code there, I'm passing in the data that I held back, I'm getting predictions, and of course I already know what the actual species of those penguins was. So I've got my predicted label down here and the actual label down here that I can compare. And it looks, just kind of eyeballing that, it looks as if it's doing okay. I mean, I can see it's got one wrong there, and there's a whole bunch of rows that just aren't shown in this visualization here. So there's actually 102 rows in total. That's my test data. 103 actually, because we start counting at 0. And out of those ones I can see, it got one of them wrong, but the rest of them right. So I could go through line by line and count up and see how well it does. But actually what I'll do is just generate some statistics, some metrics that I can use to evaluate my model. So I can use this metrics library. This is all part of something called scikit-learn, which is a library that's quite often used for machine learning. And I can go and generate some of these metrics. And the most obvious one to look at is this one right here in the middle, this accuracy. So it was 97% accurate. It got 97% of its predictions correct, in other words. And you might think, well, that's good. That's a good value. But actually, we probably want to dig a little deeper into those figures and understand a little bit more how well it's predicting for each of the different classes. So I can see I've got this column here of precision values, and I've got each of the classes here, 0, 1, and 2. So for class 0, I've got a precision of 0.96 or 96%. What does that mean? It means that of all the predictions that the model made for class 0, 96% of them were correct. So when it predicted class 0, 96% of the time it got that right. Similarly, we've got a recall measure here of 98%. And what does recall mean? Well, that means out of all the instances of this class that there actually were in the test data, and there were 45, that's what the support tells me. So there were 45 rows in the test data which were class 0, and we found 98% of them. So those two measures, two different ways of looking at how well the model's performing, both fairly high, both pretty good. And this one here, the F1, is kind of the average of those two. So I'm getting pretty high scores for class 0 and class 2. I'm getting great scores for class 1. It's really good at identifying class 1 penguins, or whatever the species is for class 1. I think it's Gen 2. I get some overall metrics for precision and recall as well. The weighted one is just to allow for imbalanced data. If I have many more rows of one type than the others, perhaps. But actually, the values are all pretty close. So I'm generally doing okay with this model. It seems to be predicting pretty well. In reality, I would probably go and try a few other algorithms and maybe try varying some of the parameters that I use with them to see if I can get a better result. But this is looking pretty good to start with. So what I can now do with this is get a visualization of how well that performance is. We've seen the metrics. Let's look at a visualization of how well it's predicting with that test data. And this type of visualization, we call this a confusion matrix. And what it's actually showing me is for my actual values and my predicted values, what are the intersections? So in other words, for all the times that it was Amelie and I predicted Amelie, then we get a value in here. And the darker the square, the more times that happened, the more instances of that occurrence there are. So what I'm looking for is exactly what I'm seeing here, a nice strong diagonal line where the actual and the predicted intersect, and that tells me, yeah, that there's good strong correlation between my predictions and my actual values. I'm actually getting pretty good predictions. There is a little bit of, you possibly can't see on the screen very clearly, but it is a little bit darker there for Chinstrap and Amelie on both sides. So sometimes it actually was a Chinstrap, but I predicted an Amelie, and sometimes it actually was an Amelie and I predicted a Chinstrap. And that's why it's called a confusion matrix. It gives me a view of where the model confused the different values. It got some of the values wrong, but in generally, a nice big long, a nice big strong diagonal line there tells me this is a pretty good model. Okay, so I've got a model. I could now go and get myself a new penguin. So I'll, as you do, go out in the street, find a penguin, and measure its bill and its flipper and its weight, and I could then feed those measurements into my model and get back a prediction. So here's the measurements of the new penguin that I found, and I get a prediction back. That's the most probable species for this penguin, the most probable class that my model is able to find. So it's predicting this thing is a Gen 2 penguin. So I've got now a working machine learning model, and that data science isn't necessarily always about machine learning, but it's certainly a large, important part of data science. But I said I was going to teach you how to be a data scientist on Azure. And so far, everything we've seen has just been straightforward Python code and training a machine learning model. So let's talk a little bit about Azure. Azure has a service called Azure Machine Learning, which lets me take this type of operation that a data scientist would do for training machine learning models and evaluating them, and do it at scale and work collaboratively in an enterprise scenario. So what I might typically do is I might take all of this code, all that code that I've just been through, and I've trained a model and I've validated the model and I've created a visualization of how well it's doing. What I might do is I might want to write a script that does all of that and run that script as an experiment. So I'm going to just run this code here. All this code is doing is creating a folder called Penguin Training and copying my Penguin data file into there. So if I go and run that code, it creates this folder, and I can actually see if I go to here, there it is. It's just created the folder, Penguin Training, and there's my Penguin data being copied into that folder. And the next thing I'm going to do is I'm going to create a script. Now this isn't going to actually run this code. It's going to create a script containing this code, and it's pretty much all of the code that you've just seen me run. It's all the things that I did to split the data first of all, and then train the model, and then validate the model. But I've added a few additional bits of code that weren't there before. I've imported this Azure ML core library, has a thing called run, and I'm getting a hold of that run, the context of this code running, and I'm using that to do some logging. So I'm logging things like the accuracy and the precision and the recall. I am logging a confusion matrix that I'm going to plot, and I'm also ultimately saving the trained model. I'm creating a file called penguinmodel.pickle because we're preserving it, so we pickle it. So I'm going to preserve that in this folder called outputs. So I'll run that code, and that will create that script. And if I have a look in my folder now, there you go, just refreshed. There's my Python script there. And what that will let me do is run that script on any compute that I have in my Azure Machine Learning environment. Well, what does that mean? Well, in my Azure Machine Learning workspace here, which is what we call this thing, I have a number of different types of compute. I have this thing that I'm running the code on right now. This is a compute instance that I'm using to run this notebook. But I also have some clusters specified here that have much more compute power. Now, obviously, I don't want to have them running all the time because I'm paying for them. So at the moment, they're pretty much idle. There aren't any busy nodes in these things. But I could run my code, my script, on one of these clusters so that it spins up the cluster just when I need it, runs the code on there, and then when it's finished, it takes the cluster down and I don't need it anymore. So if I have a lot of data, or I have a really complex model or a really complex script that I want to run, I've got the possibility to run that on compute in the cloud at scale and only pay for what I'm using. So to do that, I would connect to my workspace like this. So I'll just go and connect to my Azure Machine Learning workspace, and I'm ready to go and work on that. And then I'm going to run an experiment that consists of running that script. So here's the reference to that script, my trainpenguins.py script. And to run that, I'm going to need a Python environment. Now, I know I'm currently using a Python environment, but it all gets a little bit inception here. I'm going to use this Python code here to create a Python environment in which I'm going to run the script. And that Python environment is portable. It could be put on any compute that I need the script to run on. So I'm going to do all of that, get it all set up, ready to go. And then I'm going to run an experiment called train penguins, because, you know, who doesn't want to train penguins? So we'll go ahead and run that script. That's going to kick off this experiment in my Azure Machine Learning workspace. So we'll just wait for it to start. I get a little widget showing me that it is now running that experiment. And in fact, I'm just scrolling wildly around here. It's already finalizing that. So it's gone and run that. This run has completed. Here's the accuracy and the confusion matrix and the precision and stuff it created. But actually, if I go and have a look at my workspace and I have a look at my experiments, I can see there's my train penguins experiment. And it's been run several times as I've been preparing this. But if we have a look at the most recent run, that's the run that's just finished. I can go and have a look at that run. And I can see the metrics that were recorded by that run. There's the accuracy, the precision and the recall. I can see the confusion matrix that was generated by that run. And I can even see the model that was created by that run. There's the file, the pickle file that we created for the model. So what this has let me do is keep a record of all of the runs of this experiment. And I could run it with different parameters, with different algorithms, and I can compare the metrics that get recorded, and I'm storing them all in my Azure Machine Learning workspace. So I'm able to go and view them at my leisure later on and compare them across the different runs. And what I can also do is from that run, I can get that model, that pickle file that I created, and I can register that model in my workspace. So if I go and run that, I'll just register the model. And we'll get back a little message here. There we go. And if I actually go and have a look at that run again and scroll down, so it says registered models none because I did that after I'd looked at this. I'll just refresh it. And now it says registered model, penguin model. That's the model I just registered. And I can go and have a look at that registered model. And I stored information about the accuracy and some information about when I trained that. I trained that during an Ignite demo. So I've now registered that model, and I can come back to that model and use it whenever I need to. And one of the things I probably want to do with that model is deploy it into production. So there's the deploy option here. And I have, in fact, just to save a little bit of time, already deployed that. So I have what's called an endpoint. I've deployed it as an HTTP service There it is, called Penguin Service. So this is just a wrapper around that model that I trained in my experiment. I've deployed the model. I'm now able to use that model at this endpoint. Here's the REST endpoint, the address of that model. I'm able to use that from a client application. So I could go in and build some sort of application. I'll just get the endpoint. There's the endpoint URL. I could build a client application and put it on my mobile phone or my laptop or whatever, so that whenever I go out and I find some penguins and I measure them and I measure the different measures, so I've got 2 different penguins that I've found, I could then take those measurements, pass them to that endpoint, pass them to that registered model that I've deployed as a service, and get back the predictions of the different species. So I'm able to manage all of the experimentation and the training of my machine learning models in Azure ML. And then when I'm happy with my model, I'm able to register it, and I'm able to take that registered model and deploy it, and then use that model from an application. And that's really what Azure Machine Learning lets me do. It lets me productionize the machine learning models that I'm training using code like Python or some of the graphical tools that are in there, or whatever language I want to use. I could use R or something like that. I can train those models and deploy them, and then use them in production. So that's a very quick 25-minute kind of run of what a data scientist does in terms of machine learning, training a model, in this case a classification model, using Azure Machine Learning to run experiments on compute that's in the cloud, and then store the metrics that are generated by those experiments, register the models that are created by those experiments, and deploy those models and use them in production. We've gone through that in 25 minutes, which is not a lot of time to take everything in. We've gone at breakneck speed, so hopefully you've taken most of that in. If you don't want to do this for yourself, you want to learn how to do this and take your time over it and play around with it a bit more than we've had time to do in this session, there is actually this URL here, aka.ms Azure Learn _data scientist. And I'll take you to that and I'll show you what's there. There is an entire set of free learning on the web that you can go to, where you can learn the basics of creating different types of machine learning models. We looked specifically today at a classification model, but there are other types that are regression models. There's some details here on the stuff we did with Python to analyze the data. There's clustering models, there's deep learning models. So there's a whole bunch of different things you can learn about for machine learning. Then there's using Azure Machine Learning to create machine learning models using the graphical tools in there. And then finally, all of the stuff we did to productionize those models with Azure Machine Learning. There is a whole bunch of training there on the web that you can use to find out about that. So with that, we have a few minutes left at the end for question and answers. So Sherry, what have folks been saying during the session?
Hi, Graham. Thanks so much for taking us through all of this. So one of the questions that we've been getting a lot is if this content is, how this content is available for the audience. And to connect it to what you're sharing here, you're really saying that what you shared is a little look at what is in the data science course. So my question is, there's a lot of learning material out there. Can you explain how this course fits into the Learn platform and what certification means?
Sure, yeah. So this course, most of what we did today is actually in this first section here, the Create Machine Learning Models, and it mostly came from this course here, the Train and Evaluate Classification Models. Each of these things is what we call a module. So there's a whole bunch of these that you can take at your leisure and work your way through. This first section is really about kind of just getting to grips with machine learning. If you've never done any Python or any machine learning before, that's where to start. If you have already done some of that and you're just really interested in okay, how do I use Azure Machine Learning, then there's a set of modules here that will tell you how to use the graphical tools in Azure Machine Learning for running experiments, and there's a whole bunch of modules there. If you're actually at the point where you're ready to productionize things, you're a professional data scientist and you want to start putting things into production at scale, then there is a longer build AI solutions with Azure Machine Learning path that takes you all the way through end-to-end working with data, working with compute, creating pipelines to automate some of these training experiments, and so on. A whole bunch of different things in there that you can learn how to do. And ultimately, all of that would help you prepare for what we call our Azure Data Scientist certification. There's a certification exam. All of the training's free, so you can just go and take it to learn it if that's what you want to do. But if you then want to get the certification, there's an exam that you can take at the end of that as well that would certify you as an Azure Data Scientist.
Thanks, Graham. We're pretty much out of time. Last question would just be, is there one thing that you like best about Azure ML as a data scientist?
I think for me, the beauty of Azure ML is it means I don't have to worry about the infrastructure side of things. I can focus on writing the code that does the experimentation and the machine learning and focus on the bits that are of value to me. And I can let it take care of the infrastructure for the compute and storing the data and managing the history of the models and all that type of thing. It takes a lot of those infrastructure kind of logistics away from me, and I can focus on doing my job.
That's awesome. Well, we're out of time, but thank you so much, Graham, and thank you everyone in the audience for your questions, and have a great rest of Ignite.